Hi everyone, welcome back to our channel. In the previous video, we demonstrated how to change the density of a particular edge of a block via a schedule file. In this video, which is part 5 of Running Grid Smoother via Command Line series, we'll discuss a way to scale the density of the entire grid via a schedule file. To demonstrate this, we have a sample topology for an axial turbine blade. The blocking has 990 blocks with edge density of 3, 4, 6, and 8. Our goal is to change the density of all the block edges to 2x and run the smoothing process for 500 sweeps. In the schedule file, the syntax used to change the parameters of density is -g, label dx, where d represents the factor by which the density can be scaled. Label represents the edge label as we discussed in the previous video. By default, all the edges in the topology are set to a predefined label, all. So by changing the label to all, it will scale the density of all the edges in the topology. This would change the density of all the blocks to twice the current density. The other predefined label for edges is DEF. In a scenario where you have a topology with edges of differing densities and you are looking to apply a scaling only to change the default density, you could use -g DEF to x. This will scale the density of the edges, which has default density of 8 to 16. The density scaling should be added in a separate step so that it is not part of the smoothing loop. For example, step 1, density parameter, step x, number of smoothing cycles. As we mentioned earlier, our goal is to run for 500 sweeps. In the schedule file, the number of loops for the right grid parameter is determined by subtracting the previous step number from the current step number. For example, in the step x, if we say 5, the number of loops will be 5 minus 1, that is 4, which is 400 sweeps. Since we want to run the grid for 500 sweeps, the step number should be 6. Save the schedule file and run the grid from the terminal. We can visually check the change by loading the scaled grid in the UI. We can see that the density of all the edges is scaled to twice the original density. Note, the density is scaled to twice in all 3 directions. We hope this video helps in automating the grid convergence studies and comes handy in reducing manual grid generation efforts for the family of grids. You can refer to one such example here. Thank you for watching.